Hello and welcome to my presentation. My name is Bogdan and I am a researcher at the University of Verona in Italy. This work, robot-assisted prostate biopsy with PROST, was realized at the Robotics Laboratory Altair with my collaborators, Camilla Fiazza and Professor Paolo Fiorini. The prostate biopsy may be transrectal or transperineal, and this procedure is usually performed manually by an expert urologist. The guidance in both procedures is through ultrasound imaging. The most advanced systems includes also dedicated hardware and software for fusion biopsy. A fusion biopsy will register preoperative magnetic resonance images with intraoperative ultrasound images. By introducing a robot in a fusion biopsy, we aim to increase the accuracy and to ease the procedure. In these images, the PROST robot is tested in an ex vivo experiment. So you can see the graphical user interface and the movement of the needle during the biopsy with the virtual fixtures and all the indication to the user on the graphical user interface. So let's see the PROST robotic system, the hardware. The robot is composed by two arms that have two links and two joints each one, and four motors that move them. The arms control the position and orientation of a cannula that is constrained to pass through the top joints of each arm. A depth sensor will measure the position of the needle tip. The ultrasound probe is calibrated within the robotic system and it can be moved around its axis by the fifth motor. The workspace represents the movement of the biopsy needle and is of conical shape for each insertion point. The graphical user interface is designed as a state machine that brings the doctor through the steps of the procedure from loading the preoperative MRI images to the insertion of the needle. The insertion of the needle is manual, and the progress bar on the side of the screen allows the doctor to check the reach of the target. The interface allows two-dimensional and three-dimensional vision for a better control of the procedure. The PROST system integrates a convolutional neural network for automatic image processing through deep learning. The processing software supports the image fusion during the whole robotic procedure. This AI-based dynamic fusion distinguishes our robot from the other solutions at this state of the art. We tested the robot in several scenarios. In laboratory, we have done synthetic tests and tests on phantom, where we obtained an accuracy of around 1 to 2 millimeters. The last test performed with the robot was on ex vivo specimens to assess the compatibility with the human anatomy and the clinical scenario. In agreement with the Ethical Committee of Verona, we tested the image processing software also on human data. So here you can see some publications where we presented an in-depth description of our results. So to conclude, we introduced PROST, a new prostate biopsy robotic system. With our test, we have reached a technology readiness level of 6-7, that is the system tested on its environment. We have implemented state-of-the-art methods based on artificial intelligence to give autonomy of the system. The robotic system PROST has the potential to integrate other diagnostic devices, for instance, optical biopsy, and also therapy devices, for instance, probes to perform ablation of cancer. And this will accelerate the process of detection and also of the treatment of prostate cancer. Our advanced prototype is ready for CA clearance. So thank you very much for your attention.